Hi everyone, I have one more little add-on for the find limits algebraically. It's not exactly that I want to do in this problem, but I do want to tie it in there because it's very closely related. So what I want to do here is a little bit backwards. I want to find the value of k. I should add these to my sheet so I don't have to write them. Of constant k even, so that the limit exists. And find the value of the limit. Okay, sorry you have to watch me write directions. First one is the limit as x approaches 1 of x squared minus kx plus 4 over x minus 1. So the idea here is that I want this to be a nice limit. And right now, if x approaches 1, the bottom is going to 0. The only way that's possibly going to work out nicely for me is if the top also approaches 0. If the top approaches something else and the bottom is going to 0, you're going to have asymptotic behavior, which is not what I want. And in particular, if this thing isn't squared, that's going to force this to be a does not exist. The reason the squaring matters is if this whole thing was squared, that's what forces the asymptote to head the same direction on both sides. So both sides head to positive infinity or both sides head to negative infinity. So if you don't have that, your only chance is to make this a 0 over 0. Another way to think about this is I really want to make this factor so that one of the factors is an x minus 1. So the two lead to slightly different ways of figuring out what k has to be. If you want to use the factor idea, you would say, okay, well, if I want an x squared here, then this also has to be an x. And if I want a 4 here, then this has to be a minus 4. And if you multiply that out, you get an x squared minus 5x plus 4. Since there was already a minus built into this, that means that k has to be 5. So there's one way to figure this out. K equals, oh, I'm going to be sad that I wrote that there. Here, we'll write it down here. K equals 5. If you're looking at the just how do I make it 0 over 0, you can plug 0 in for plug 1 in for x. There we go. We want the top to be 0 when x equals 1. So if x is 1, we have 1 minus k plus 4, which is 5 minus k. So we could say if x equals 1, so this is alternative. You don't need to do both. If x equals 1, then I have 1 minus k plus 4, which is 5 minus k, and I really want that to be 0, which once again means that k equals 5. So a couple different ways to do it. Basically, you're trying to make sure it's a removable discontinuity. Okay, so k has to be 5 is the answer to the first part of that question. In terms of finding the limit, let's see if I can make this legible with that k there. We would want to factor this thing. So we'd say we have x minus 1, x minus 4. We already wrote this up above. And then we can cancel the x minus 1. And as x gets really close to 1, this is going to get close to 1 minus 4, which is a negative 3. So that's the answer to the second part of the question. K has to be 5, in which case the limit will be negative 3. Okay, let me just show you one more. What if I want to work on the limit as x approaches k of x squared minus 9 over x minus k? All right, so maybe a little bit trickier in this one. I do have, once again, that if x is really close to k, the bottom is definitely close to 0. So I'm back onto that whole, I want it to be 0 over 0. If it's anything else, I have no chance of making this thing behave nicely. It's going to have asymptotic behavior. So for the top, oh my God, caught me. In this case, I don't get to choose anything about the top, but I can see what would make the top 0. The top is 0 if x is plus or minus 3. So if we want this to be a 0 over 0, we want x to be approaching positive or negative 3. So basically in this one, k could be either positive or negative 3, and that would make it a 0 over 0. So that turns this into the limit as x approaches plus or minus 3, which is really going to be two separate questions, of x squared minus 9 over x minus plus or minus 3. I don't know why I'm writing it this way. This is weird. So let's split it into two problems. Okay, so the limit as x approaches positive 3 of, I'm going to go ahead and write the factors out, x plus 3, x minus 3 over x minus 3. So this first one is if x approaches 3, this is going to go to 6. So if k equals 3, then the limit is 6. That's kind of terrible shorthand, but just so that you can see what I found. And then if we do the limit as x approaches negative 3, we have the same top, x plus 3, x minus 3. And now on the bottom, we have x minus a negative 3, which becomes the x plus 3, which we can cancel. And if x is close to negative 3, this is going to be close to negative 6. So if k equals negative 3, then the limit will be negative 6. All right, thanks for watching.